Okay, now this is pretty cool. You really, I wouldn't spend too much time learning this Mills method, but if you like it, maybe you'll latch onto it. Um, 56x squared minus 11x minus 12 equals 0. I'm saying use factoring to solve this equation. This is a pretty ugly use of factoring. It's a pretty ugly problem for factoring. And again, I'll show you the cheat and how you really never have to absolutely learn this, but you probably should have some idea of the connection between how to factor and solving these things. So anyway, without further ado, my Mills method is find the magic number. I call this the magic number. A times C, 56 times the minus 12. See that 56 times minus 12 is minus 672. And now I know that the middle term is always going to add up to minus 11. So I'm going to find numbers that add up to minus 11 and try to multiply it if they multiply together to get minus 672. And here's just a couple. Minus 11 is the same as, let me maybe drag this down. Oh, let's see, minus 12 plus 1. And then if I take the product of those, I get minus 12. Hey, I'm going to have to go a lot farther than that. Minus 13 plus 2, minus 26 if I multiply them together. And see how I'm coming closer? Let's see, minus 20 plus 9 is a minus 8 minus 180. It looks like I got quite a bit farther to go. Um, minus 21 plus 10 minus 210. Oh, come on, Steve. Minus 30 plus 19. 3 times 9 is 27. And 3 times 1 is 3, carry the 2. Minus 570. I'm getting closer. Minus 35 plus, what, 24? 35 minus 24 is 11. Yep. And let's see, minus 35 times 24. Oh, I don't want to do that. 35 times 24. This is kind of using a sledgehammer for 35 times 24. This symbolic algebra package that I'm using to multiply two whole numbers together that I should be able to do by hand. 840. Looks like I went beyond. So it's going to be somewhere between these two guys. See here, it's still under, in a sense, under the 672. Now it's kind of over, in a sense. So the first number I'm going to use is like something between minus 33 plus 22. That's not going to do it. Now I'm looking for a number that ends in 2 here. So minus 34 plus 23. 4 and 3 is 12. I think that might give it 34 and 23. Please be 672. No, 782. Well, I'm getting closer and closer. Um, I did 33, 34, 32 plus 21. Please, please be, yes, be 672. Negative 672. Sweet! So what this tells me is that those are the two that are going to work. So it's a 56x squared minus 11x minus 12 and what my work just said is I'm going to split that 11 into a minus 32x plus a 21x minus 12. Now, it might not immediately be obvious that this is going to work, but it actually does. You need the greatest common factor of the 56 and the 32, and it turns out that you can pull a factor of 8x out of 56x squared to get a 7x, and then 8 into 32 is 4. And on the second one of those guys, pardon me, I'm just cleaning house here. The greatest common factor between 21 and 12 is 3, and 3 goes into 21x, 7x times, and 3 into 12 is 4. Oh, and look, I can factor out a 7x minus 4 here. And that leaves behind an 8x plus 3, and that's the factored form. Now, I'll show you the sledgehammer on this in a minute, and it's actually quite a bit quicker for this problem. I just did want you to see that slightly different approach to the AC method than you probably have ever seen. 7x minus 4 equals 0. That says 7x must be 4 when I add 4 to both sides. Now divide both sides by 7. X equal 4/7, or 8x plus 3 equals 0. So subtract 3 from both sides, divide both sides by 8. That's about as clean as you can be and still be complete as far as the steps go. But let's go ahead and clobber this with a quadratic formula real quick, and I'll just show you the cheat for these. Now we know that the zeros are x equal 4/7. I'm not going to do the quadratic formula on this one. I'm just going to use these two guys. X belongs to minus 3/8, comma, 4/7. And I'm just going to reverse engineer the factorization from this. So here's the cheat. From quadratic formula. And people, wherever possible, I'm not going to be impressed if you convert that 3/8 to a decimal and the 4/7 to a decimal. No, leave it as a fraction. If you can't get that fractional answer, it just says that you're not manipulating objects the way I want you to manipulate them. We want to be able to manipulate things and work with fractions, not just, oh my God, a fraction, I got to get my calculator. No, you want to be able to manipulate fractions because in algebra, we manipulate fractions in the abstract. So if you can't manipulate fractions in the concrete, you're hopelessly ill-equipped for manipulating fractions in the abstract where there's variables instead of actual numbers. That's the one thing where dependence on a calculator can really hurt you. Okay, so the quadratic formula got it for us, say. Let's reverse engineer the factorization. And you do need to display factorizations in calculus. There's a thing called partial fractions. Where you must display the factored form of a polynomial. So you do need to know that. But there's nothing that says you can't use a sledgehammer to do your factoring. The cheat is here. X equal minus 3/8. That's x minus a minus 3/8 is a factor. And x equal 4/7 is a 0, x minus 4/7 is a factor, and what we need out in front to make this fly is just that 56. See that 56? That 56 needs to be there. And now, look, you see how the original factored form and the factored form we eventually got was 7x minus 4 times 8x plus 3. You achieve that by splitting that 56 into appropriate factors. So here it is, appropriate factors for 56. I'm thinking 8 times 7. Use a distributive law to, or not the distributive law, but the commutative law of multiplication of real numbers to put the 8 with the first factor, the first binomial factor, and the 7 with the second binomial factor. And now you can distribute the 8 into the quantity, 8 times x, 8 times, oh look, 3 times 8 is 24, but the 8's cancel each other. Sweet! Yeah, and you want to do enough of these looking at factored forms of things to be able to just read, look, x equal negative 3/8, x equal positive 4/7. If I see the factored form, I have no qualms about a student jumping straight from that factored form to a solution of minus 3/8 positive 4/7. No problem. Okay,